Assalamu alaikum wa rahmatullahi wa barakatuh. Good day to everyone and doctor. We are going to present about Lajak tablet and we are group A under the supervision of Dr. Siti Rohani. I am Nuruddin Ashraf and this is my teammates Hasna, Wong, Hamad Rashad and Abdurrahman Taif. And here is our content. First we will start with the summarizing of sample data in three different forms: numerical form, tabular form and graphical form, and then the goodness of fit test. First, the hypothesis statement, and then the data collecting and rejection rule, then the ANOVA by also the hypothesis statement first, and then the output data, and then conclusion. Last but not least, the regression and validation of the linearity model, the hypothesis statement, and model analysis. And then we will conclude the work.
Assalamu alaikum, my name is Abdurrahman Tahir and I will continue after Noor to present the summarize of sample data. The numerical form for the weight and the relative density percentage and the tensile strength. For the first one, the sum of weight, and we have the sum of weight and we have the count of weight, average of weight, max of weight, standard deviation of weight, and variance of weight. The second one we have is the sum of relative density, count of relative density, average of relative density, and max of relative density, and standard deviation of relative density, and variance of relative density. Last one we have is the sum of tensile strength, count of tensile strength, average of tensile strength, max of tensile strength, standard deviation of tensile strength, and variance of tensile strength. The second form we have is the tabular form for the weight and the relative density percentage and the tensile strength. The last form we have is the graphical form for the frequency on weight and relative density percentage and tensile strength.
Goodness of fit test is used to determine whether the weight of standard tablets produced by manufacturers follow the normal distributed with 350 mg with standard deviation 40 mg and assume alpha value is 0.05. For the rationale, which is the hypothesis statement, the weight of standard tablets follows the normal distribution with mean 350 mg and standard deviation of 40 mg. For H1, the weight of standard tablets does not follow the normal distribution with mean 350 mg and standard deviation of 40 mg. So the calculation will be shown in the table beside. So after we calculate the chi-squared test value, so the obtained value is 6.61 for the chi-squared test calculated, and for chi-squared 0.058 is 15.5073. So that's a conclusive rule. Since chi-squared test which is 6.61 is less than chi-squared 0.058 which is 15.5073, thus H null is accepted at 5% of significant level. We can conclude that the data do follow the normal distribution based on the requirement with mean of 350 mg and standard deviation of 40 mg.
So the next is the analysis of variance or ANOVA. So first we are using the Microsoft Excel to separate the data week into 3 existing shifts, the night, morning, and evening. And then we decide if there was any difference occurring in the means of the data. Then we use analysis of variance or ANOVA. The hypothesis statement is H0 equals to mu1 equals to mu2 equals to mu3. And then the H1 is at least 1 mu I not equal to mu j. So I is not equal to j. This is the table of the summary of data. We can know that is this. We can know this is the groups, count, sum, average, and variance. The next is, from the output table below, it shows that the F value that we get is 0.0539, the P value is 0.9474, the F critical is 3.0417, so the P value is more than 0.05. It means that the H null will not be rejected. And these are the table of showing the significant difference between the data.
And here, part D, which is a symbol interpretation. A symbol interpretation where we can find the relationship between the dependent variable y, which is tensile strength, and the independent variable x, which is relative density. The requirement here is to predict the tensile strength for relative density of 68%, 74.3%, and 80.1% based on the data. The relationship can be y equal alpha plus beta multiplied by x. Here we can see the multiple r, which represent to the strength of the positivity or negativity of the relationship. So with this case, it is very strong positivity because it is 0.57282965. Also, we will predict the valid tensile strength based on the symbol data 200. Here with this table, we can find the value of alpha and beta, where the alpha is coefficient interception 0.1728741, and the beta is the value coefficient at relative density 0.079196469. Hence, the equation obtained here, y equal 0.0791 multiplied by x plus 0.1728. Therefore, we got predict y value, which is 5.55 for 68%, 6.05 for 74.3%, and 6.52 for 80.1%. However, the linear regression relation cannot be used to find an extrapolate points, which means we can only predict y if x is ranging from 83.7% until 92.9%. Therefore, the prediction values obtained is not valid to predict the tensile strength for relative density 68%, 74.3%, and 80.1%.
So to conclude the work for the status of protection of Bell tablets in December 2020, we conclude that the production do follow the normal distribution. And also there is no significant difference exists between tablets weights from the different shifts. Besides that, the relative density and tensile stress data provide a very strong evidence on the existence of linearity in the regression model. And lastly, there is a strong positive linear relationship between relative density and tensile strength. This is all from Group A. Thank you for your attention. Goodbye.